everyone, thanks for watching How To Pixel, and this is the 2023 Christmas light show behind the scenes tour. There's a lot of stuff to get into, a lot of new things added to the show, a lot of mess of cables to get into, and I'm going to be talking about what all this stuff does in this video. So, let's get started. So two things before I get started with this video. First, like always, I'll have all the timestamps in the scrub bar below in the description, so you can skip to whatever part of the video you want to see. If you want to jump right into how everything's built outside, or jump into something over here, you can use the timestamps and skip to that part of the video. And then second, if you're brand new to light displays and pixels and all that, but you have no idea how they work, you want to learn how to set up your own display, this probably isn't the best video for you to start with, because I'm not going to be going fully in depth on how each individual piece works and what it does. If I did, this video would be hours long. This is going to be more of a little bit of an overview of how everything works together and what there is and what all the pieces are that go together to make this light show setup. So if you're looking for some tutorials to get started with a light display and figure out how everything works and the very basics of it, then I recommend you check out this playlist right here. I have a bunch of beginner pixel tutorials so you can get started on your journey to building your own light display. But if you have at least a little bit of knowledge on pixels, then you could stay and keep watching this video. But with that, let's get started and take a look at all of this. So this whole area right here is the main control center. This is where all of the computers and most of the controllers are. There are a few controllers that are out in the yard, but almost everything is controlled by this whole setup here. There's multiple different stages, if you want to call it that, to this setup, and the first one starts with power. The first stage is you need to get power to power everything for the pixel lights. Now, pixels don't take a whole ton of power, so I don't need to have the entire power grid in my house with outlets everywhere and a giant control panel. Everything in the whole show is powered by this outlet box, and this outlet box goes to this sub panel right here. That outlet box is on its own 20 amp breaker, so I could take up to 20 amps on the AC side and not pop a breaker. For a lot of setups, you won't even have to do any of this. We didn't have this sub panel here, but the only outlet option was that one over there to control the light show, and that was hooked to our kitchen, so we didn't have enough power because anytime we turned on the microwave, the light show would shut off. But if you have outlets in your own garage that don't go to anything else, you probably won't need to put in a whole sub panel like we did. I talk more about this in other behind the scenes videos like I showed with the Halloween one, so I'm not going to go into any more detail about it. Just this outlet is on a 20 amp breaker. Almost everything for the show is controlled by these smart plugs right here. I have two of these smart plugs. I can never remember how to say the name of these, but you can control these from your phone, set up schedules for when to turn on and off everything. These are probably more cheaper smart plugs. They don't have many features other than you can turn them on and off with your phone and set up schedules. There's others that can measure amperage, voltage, and a ton of other stuff. You can only run up to 10 amps or 1200 watts off of one of these. So I have two. One might be enough, but I can't plug everything into one because I ran out of surge protector space. I really need to get a third one of these because I have a lot of stuff just plugged into these two. So I think next year I'm going to get a third one. That way everything's a lot more safer and I don't have a ton of these splitters in the entire show. The only thing that isn't controlled by a smart plug is this cord right here, which goes up to a router up there, and I will talk about this router in a second. This first smart plug right here goes into this surge protector, which has a ton of extension cords and stuff plugged into it, and it also has this splitter plugged into it with two Raspberry Pi power supplies. I know in the Halloween behind the scenes video I talked about getting rid of this, but I actually never got a chance to look into other options besides having a splitter plugged into a surge protector plugged into a smart plug, and that's another reason why I said I need a third smart plug. That way I don't have all of these cords running off of one thing. Almost the entire light show is on this one surge protector. All of the pixels are, all of the computers, and almost all of the controllers are on this one smart plug. The things that are on this smart plug is the panel that we have, the P5 panel build we got this year, and a DMX bracelet transmitter, which I will get into later. These three orange extension cords come down here into this giant cable where I have all of the extension cords, and they go out that way, down out the garage, and they go to three controller boxes in the yard. This black extension cord goes to the main controller that I have in here, which I'll show in a second. This cord right here goes to the FM transmitter, and then these two plugs go to the two Raspberry Pis I have out here. So if we go up to the second story of this shelf, you will see there's a lot of other stuff up here. This is the FM transmitter right here. The cord from down there goes up around the back. I really don't like having cords everywhere, so you'll notice that I have everything zip tied and wrapped together to try and make it look as neat as possible. This FM transmitter right here is the CZE-05B FM transmitter. I've used this every year for the show since 2020. It still is working amazing, and it's the best budget-friendly transmitter, I'd say. Now, when you hear the price, you might not think this is budget-friendly. I got this for, I think, $80 or $90. It's now in the hundreds. I think it's like 100, maybe 110. But this is a budget transmitter because other ones can go to $200, $300. And then there are ones that are a lot cheaper than this too, but they have terrible quality and don't last long. With this one, I could set it to whatever station I want. I have it set for 90.7, which is a open station in my area. I can adjust the volume, and I can plug in a microphone too. The audio comes in right here from my Raspberry Pi. And then a neat thing about this is if I leave it on and I was to cut the power to it, like turn off the smart plug, it would turn off. But when I give it power, I don't have to hit the on button. It will remember the state it was in. So it lost power when it was on. So when it gets power again, it will automatically turn on. And I don't have to hit a button every time to turn it on. And then it has the stock antenna on it right there. It's not even that tall. You can see the top right there. And that antenna goes plenty far. This transmitter even has two settings on it. It can have 100 milliwatts of power or 500 milliwatts of power. I leave it at 100 milliwatt because that's plenty far enough. If I put it at 500 milliwatt, it goes even farther, way down the road, and I don't want to get in any trouble, so I leave it at the low power setting. I'll leave a link to it in the description, and I'll try and leave links for everything I talk about in the description below. If we move over here, we have two Raspberry Pis. This is the main one, and then this is the remote. These two Raspberry Pis are running Falcon Player software, which is, if you don't know, a software that is used to set up your schedules, and it has a ton of features, and you can use it to send the data from here. This is a show player, and you can send the data from here to a controller. If you want to know how to set it up, I'll leave a video right up there that you can check out to see how to set it up. So this is the master Raspberry Pi, and this is the remote Raspberry Pi. This Raspberry Pi controls all of the pixels. This one controls the panel screen. I talk about it in my Halloween behind the scenes, but I tried to run everything off of this Raspberry Pi, and for some reason the lights were skipping and lagging, so I had to get my other Raspberry Pi out. But when I added this, it made everything work a lot better, and the panel and the lights didn't skip. The master Raspberry Pi has power coming in here, and then it has an Ethernet cable. It's a little hard to see right here. It goes into this roll, into this router over there that I'll talk about in a minute. And then it has a Sound Blaster Play 3 plugged into one of the USB ports, and that converts the sound from USB to an audio jack that can be plugged into there. You can just run the audio right out of the audio jack on the Raspberry Pi, but the audio quality isn't as great. On the second Raspberry Pi, all that's hooked to it is power right here, and then an Ethernet cable, which doesn't go to the router actually. This goes right to the screen, and I'll talk about that also in a minute. Moving over, we have this box right here, and this is the DMX bracelet controller. For those of you that don't know, I have these bracelets in my light show. They have a single LED in them, and they sync to the show, and this is what controls them all. It sends a wireless signal to all of the bracelets, and it controls them all. It's not that complicated to set up. This can run right off of my Falcon controller, and it's also a fairly cheap setup. I think it's around $150 for this transmitter, and then maybe like $1 a bracelet. I'm not sure, with inflation it's gone up a little bit. But I talk about how you can run something like this in your show right there, and you can check out that video. This has power going to it right here. It has a power cable. I cannot move anything, so I have to move my phone so you can see it. It has power coming in right here, and this goes into the second smart plug with only the screen on it. It has an Ethernet cable right here that plugs into the controller, and it goes into this Ethernet to XLR adapter. This takes an XLR cable for data, but this converts DMX data from my controller into the XLR cable to plug into here. And then it did have an antenna with it that was super long, but I put in this little tiny wire into the antenna hole, and it works great. I got rid of the longer antenna because I was having a lot of problems with this thing. This thing uses the same signal that newer cars use with their key fobs. So whenever the bracelets are on, nobody can start or unlock or lock their cars in the neighborhood. I shouldn't say in the neighborhood, it's actually only a few houses around, but it's a very big problem. So I tried to reduce the range of it, and And the reason I also have this on a smart plug separate from the light show is if any of my neighbors can't get their car working, I can go in and shut off just the screen and the bracelets, keep the light show running, and then when they message me that they got it working, I can turn it back on. I also have parts in my light show where the bracelets aren't on, so if their car won't start within 10 or 15 seconds, there should be a quick dead zone that they can start it. So that's why this is on a separate smart plug. And then the final thing on this shelf is this router. Now, if you've seen the Halloween behind the scenes video, you'll know that I had a network switch, but now I have a router. The reason for that was because there's a huge problem with networks and stuff, and I'll talk about it now, but if you don't want to hear about this, skip to this time in the video, or just go through the chapters in the scrub bar, because this part might be boring for some people. So originally, the master Raspberry Pi and my controller over there, which I'll show in a minute, were hardwired into a network switch that then went through this white Ethernet cable up there into our attic over there with a bunch of power wires and stuff, and that plugged into our router in our living room. And then this Raspberry Pi, since this has to be hardwired into the screen, the only other way to connect to it is with Wi-Fi. So this was connected to our router with Wi-Fi. But when I started the Christmas light show this year, I only had a network switch, but then I noticed whenever the light show started, our internet speeds would drop. And I'm not talking just like a little drop, it would drop drastically. Our internet speeds are usually anywhere between 200 and 300 megabytes per second download. It went down to 10 megabytes per second when the light show was running. And I couldn't figure out why our network was so slow, and it took me a few days till I realized it only happens at night. And that's when I thought, maybe all of the data this Raspberry Pi, and the controller is sending from the network switch is somehow clogging our router. Now, I know a little bit about networks. I know how to set them up. I know how to get the Raspberry Pis working, but I'm not an expert at it. So I thought the network switch would be able to keep the data from the Raspberry Pis and the controller within there. With the exception of this Raspberry Pi, since it's over Wi-Fi, that obviously has to go through Wi-Fi into the network switch here. But somehow that data must have all been going to a router and clogging it up. So what I did is got a second router, and now there's a separate light show network for all of this stuff. This Ethernet cable now comes from our router and goes into here. So this router is plugged into our main router that's plugged into our modem. This is hooked up via WAN to WAN. I think that's what it is. I'll put it on the screen if I'm wrong. So now this has its own Wi-Fi network, and this Raspberry Pi is now connected to this with Wi-Fi, so it's only this little area. And then the rest of the stuff, the Raspberry Pi and everything else, is also connected to this. So now all the light show data is separate, and there's a separate Wi-Fi network. It's not super fast, but it still works with all this fine. And all the Raspberry Pis and controllers still have Wi-Fi connection since this goes to a router. But now the other problem I had is anytime I wanted to connect to any of these Raspberry Pis or the controller, I would have to disconnect from our Wi-Fi and connect to this to be able to talk to it. Then someone I knew who is really good with networks and stuff showed me a way to connect to this from my other router with port forwarding, I think it is. I don't remember the exact way. I do know how to set it up if I need to again though. I have a networking video that I want to make in the future about how to connect all this with the networks. I might talk about how I set that up. I can't talk about it now because I don't remember. I have to look at the web interface for this to figure it out. But that is the entire networking story. Now let's continue with the behind the scenes. The final thing back here is the main Pixel controller. And inside here, I have an F16 V5 and a 12 volt power supply. This F16 V5 is the main and only Pixel controller I have. It has 3 chains of differential receivers plugged into the RJ45 connectors. It's hardwired into the router. I just got done making a 2-part tutorial on how this controller works. It is a revolutionary Pixel controller, so many awesome features, and I highly recommend, if you don't know about this controller, to check it out right here. This controller is from Falcon, it's F16 V5, and basically this controller got rid of the expansion board thing. I used to have a differential expansion board right here that plugged in my F16 V3, so I could get differential receivers to hook off of this. But the F16 V5 basically took that differential receiver expansion board and put it into the controller. So now there are 4 RJ45 connectors that you can plug up to 4 chains of receivers into. This new controller allows 6 receivers per chain, so I could have 24 differential receivers plus all of the 16 pixel ports off of this controller. I only have 3 strands of pixels plugged into it. I have ports 14, 15, and 16 going to things. These go to the garage, and all of the lights on the front of the house. The door, the windows. This Ethernet cable right here is the DMX cable, it plugs into the RJ45 connector here, and this goes to the bracelet controller, and this is what controls the bracelets. And then these 3 Ethernet cables right here go out to the differential receivers in different locations in the yard, which I'll show in a second. And then over here, there's a complete mess of cables down there and up here. Those 2 cables are the 2 cables that go to the screen. It's a extension cord and an Ethernet cable. The one Ethernet cable goes to the remote Pi right there. I used to just have them laying on the ground going underneath the garage down here into the screen, but it was annoying because it was in the way, and anytime we wanted to come in here, we trip over them. So what I did was I took those 2 cords and ran them up here above the garage. I had to make sure I had a zip time in a bunch of places so they didn't get caught in the garage. And then they go out of the garage right up there. They barely fit, but they go out and down into the screen, and I'll show that in a second. But that way, now there is nothing in the way. We can open and close the garage perfectly fine and not have cables on the ground. And then all of the other cables, these 3 data wires for the pixels, a bunch of Ethernet cables, I have them all wrapped up here. These are the ones that go to the yard. I have them wrapped up nicely so they're not all over the place. Another wrap of Ethernet cables, one of them doesn't go to anything anymore. This used to be for the fog machine, but I didn't feel like unzip tying it from all of the other wires, so I just left it there. And then all of the extension cords, they all come down, and even the wires that come to the screen, they were really long, so I had them come down and then go back up just to keep it nice. Everything comes down here through all of these cords, zip tied together, and then some of them I have shoved under there. They don't go to anything. I just did that so they're out of the way. I have some pigtails there for the 3 data wires for the pixels, and everything comes out this hole, going out to the yard into a bunch of other places. And I call this the highway of cables. It's like a whole interstate with 6,000 lanes going in both directions. That's what all of these cables are like. So that's everything in here. All of the cables end up going that way, and now we can go outside and take a look at everything out there. Now, before I continue on and show you what's outside, I want to let you know that this is a cut right here in the video. I wanted to finish recording everything outside when I finished the part in here, but then it started snowing, and that was before Christmas, and then I got busy and couldn't finish it. So now that it's New Year's Day, before I clean up everything, I'm going to try and show you it now. So the first thing I wanted to show you that I have the 2 wires for the screen, the power, and the Ethernet cable. They come down here, and I have them taped together so they don't separate. And those go in to the bottom of the screen. This is the screen right here. It is made out of P5 panels. It is 7 panels by 8 panels tall. And I've already talked about it separately in the Halloween behind the scenes and in its own video, which I'll attach up there. So I'm not going to talk about it here because there's a lot to it and there's a lot of other stuff I have to get to for the show. Out here where the highway of cables is, like I call them, we have a lot of Ethernet cables, data cables, and power cables. One Ethernet cable and a power cable come up from the hole right here. That's all the stuff that goes into the garage. That goes up there and it goes to the box, the controller box on the roof that controls everything on the roof. The only items in the display that are attached directly to the controller, not through a differential receiver, is the garage right here and almost all of the windows from that window, the second to last window, over, all of that is directly on the controller. I've also already talked about how the windows are set up and how the garage is set up in the Halloween behind the scenes, so I'm not going to explain that again. But down here with the one window on the end and this wreath, this window used to be hooked directly to the controller. It's not anymore, and I'll explain that when I get to this part. I think I mentioned this earlier in the video. There's 3 controller boxes that are hooked that go into here to the controller. One of them is the one on the roof, one of them is in the tree right there, and then the other one controls everything in the yard right there. Now right here underneath the door, there are 3 cables that go to that direction. There's 2 Ethernet cables and 1 extension cord for power. And then there's this yellow Ethernet cable and this other extension cord that goes to the tree controller box. And there's also a data wire that hooks directly to the controller from the door that goes to this window. But these 3 wires that go to the yard come down here and go to this controller box right here. The extension cord plugs right into the controller box cord right here, and one of the Ethernet cables goes into the controller box. The other Ethernet cable is just right here. It's rolled up. It doesn't go to anything. This used to go to the fog machine we had for the Halloween light show right here, but I didn't feel like untaping the entire cable and taking it all out, so I left that, and when I'm done with this video, I'm going to be cleaning all of this up. Now I'm going to show you what I have inside this controller box. Something quickly I wanted to mention that I always forget to say All of these controller boxes in the light show are Cable Guard 1500 enclosures. You can find them on Wired Watts and a bunch of other places that sell pixel supplies. So in here I have one 12-volt power supply. This is a Meanwhile power supply from Wired Watts. It converts 120 or 240 AC volts down to 12 volts DC, and that's what all the pixels run on. This one box controls everything that's in the yard. It controls all of the candy canes, all of the arches, all of the pea stakes, the Toon sign, and the mini trees. There really should be two power supplies in here, and when I was putting everything together and ordering stuff, I thought I had enough power supplies, but when I went to put this controller box together, I couldn't find the other one, and I realized I bought one too few power supplies. So this power supply is right on the maximum amperage you can use off of it, but it worked okay for the show. Next year I'm gonna get another one to put in here. And then I have two differential receivers that are on one chain of the F16 V5. These are the V2.01 receivers. Next year I'm hoping to get V5 receivers, or whatever is the newest receiver, for every single box. There's only one box that has two V5 receivers. The Ethernet cable comes in right here into the bottom part of this differential receiver, and then the other one is chained off the other Ethernet port from here. There are a lot of things plugged into the power supply. The two receivers are plugged into the power supply, and then I think there's 3 power injection cables that are plugged into there too. On the first receiver we have arches and candy canes on here. They're chained in different patterns, so I'll show you that when I show you the candy canes and arches. That's on the first receiver. The second receiver has another arch on it, the Toon sign, the pea stakes, and the mini trees. I have 30-inch female Raywu pigtails plugged into the terminals. They all come out down there. There's a whole mess of them. There's also fuses for the power injections. They all come down here. I tried to keep it nice. I got these labels, which have been doing okay. The permanent marker seems to be fading off, but I'm going to use these a lot for storing things. They're these little labels. You can tape them to cables and whatever, and you can draw on them. And I tried to label everything. Like this says R1P2, so this goes to receiver 1 port 2. These ones you can see that are even more faded. These ones have been out here since Halloween, so they do seem to fade after a little bit, but they'll still work fine for storing things. That way I can label which wires go where. And then that's everything for this controller box. The way we have this holding is we have a board that is on the back. We screwed the controller box to the board, and then we did have stakes for this, the stake in the ground, but we couldn't find them at the time. So we just took pieces of, I think it's 3/4 inch PVC pipe, and we screwed that to the board and staked that into the ground. So that's what holds up this controller box. It stays waterproof, no water gets in it. So now I'm going to talk about the wiring for all of the candy canes, the arches, and the Toon sign. There's 5 ports that go to all of these things total. On the first port, it starts with this candy cane, then goes to this arch, and it ends there. These candy canes are from Biscoyo. They are the 36-inch candy canes. They have decor, so during the day it looks nice. They have 99 pixels in them, but if you want to get one of these, make sure you get the 100 pixel ones. They updated them and put an extra pixel right there, because it's very annoying having 99 pixels when you get your strands of pixels in 100. You have to cut off 1 pixel and solder a pigtail onto it. So what I did was I just left the extra pixel off of it and was going to try and null that pixel in the controller, but for some reason with the F16 V5 and V2 receivers, pixel nulling was not working. There's a bunch of random things going on. So in X-Lights, I just programmed this 1 pixel to be a single pixel, but I never program it to do anything. So it just basically passes the data. The wiring for the candy cane, I have it set for the X-Lights default. It starts off here at the bottom and zigzags back and forth over 2 rows. Doesn't go into the row to the left, and it zigzags till it gets here. Then it goes around the final row. That way you can have your pigtails at the bottom of it. And then we took a piece of rebar that you could see right here. It was a little bit longer. It went to about here, and then we staked it into the ground, and it held it okay, but the candy cane kept trying to spin side to side. So I took a bunch of zip ties and hooked them together and hooked them to the arch on each side, so the arch prevents it from spinning. And then it does move back and forth a little bit, but it was okay. We didn't get any super high winds. And then inside I have regular bullet pixels. You can't really use this with square pixels or flat pixels because they don't fit in the holes all the way. But I really love these candy canes this year. There was a lot of cool effects I could do on them. And this is the exact same for all 4 candy canes. All 4 of the candy canes are built the same way. Then for all of the arches, depending on where it is on the line, the data will either come in on the left or the right. For the last 2 arches right here, the data comes in on the left. And for the 3 arches over there, the data comes in on the right. The way these are built is there's a piece of 1/2-inch PVC pipe in the board, and it goes up into an arch shape. Then it goes into the other side of the board. And then I have these pixel holders from Biscoyo. They're the large arch one. I think they're $7 or $8 a piece. It comes in 3 sections. So you have one section down here, you have another section up here, and then the final section down there. These are meant to hold 51 pixels. But then again, instead of cutting off an extra pixel, I don't want to solder on an extra pixel because keeping strands in 50 is easier than 51. So I don't use the last pixel. But as I'm saying this, I literally just had an idea. Why didn't I take that last pixel from that arch or from this candy cane and start it? Well, it might not have reached. Okay. I just had a random thought. If I had taken this last pixel and put it in here, then the other 50 would have filled the whole arch, but it wouldn't have reached anyway. So that was just a random idea I had. These come with zip tie holes about every 2 or 3 inches, I'd say. And I forgot to mention, the candy cane also has zip tie holes pre-cut into it. We didn't use every single one. I used every other one. If I had more zip ties, I probably would have put more zip ties in here. But I only put 3 zip ties per section for the arch. But it's all one strand of 50. And I have each section, it's all zip tied to the pipe. The pipe holds it in fine. And then when I'm done for the year, I'll cut the zip ties, take the lights off, and I can take the PVC pipe out of the wood frame, and it makes it easier for storage. For the wood frame, what we have here is a 2x4 that goes across, and then we have 2 2x4 legs on each side. And over here where it hangs over, there's a hole in the board that the PVC pipe goes into. So we stick one end of the PVC pipe in here, and since 1/2 inch is easily bendable, we bent it across and then put it in that hole, and then it makes the arch shape. That's how the arch is built, and that is the same for every single arch. So this is on one port, this candy cane, then that arch, and then there's no power injection. I tried to keep the least amount of things on the port so we could have less power injection. Then on the next port, the second port of the first receiver, we have the next candy cane and this arch. Then for the third port, we have this arch. So instead of the candy canes being first, it's now the arch and then that candy cane. For the final port of the first receiver, we have this arch. This is the second arch, and then that candy cane. All of this so far has had no power injection. And then starting on the second receiver on port 1, we have the final arch and the tune to sign. The data comes in starting at the arch, and then it comes out and goes to the tune to sign. And this does have power injection because the tune to sign has a lot of pixels in it. This Tune 2 sign is from Biscoyo Studios, like most of the stuff in the show is. It has 191 pixels, I'm pretty sure. That's if you use the same number as I have, the same numbers. This is a custom printed Tune 2 sign, so it comes automatically with the Tune 2 and the border, and then you tell Biscoyo what number you want them to print for you, and they will cut out the holes for you, and then you can put the pixels in. So my station is 90.7 FM, so they punched holes for 90.7 FM. The only thing I don't like about this Tune 2 sign is it doesn't come with a wiring thing and X lights, because there's like 100 different possibilities with different numbers. So X-Lights doesn't have a wiring diagram for it, so you have to wire it yourself, then tell X-Lights how you wired it. I used a website called Light Show Hub, and it made it a lot easier to wire it. And then in the back, we just have bullet pixels going into it again. This is really thick, really sturdy. It's not going to break at all. We have data coming in there, and then power injection there, and then in the middle, this was a strand where we hooked 2 together. And then to have it staked into the ground, we took stakes, which were actually that box's stakes, so that's where these went. Put 2 on each side, screwed them in, and then we put a board on the back just to make sure it doesn't tip either way. And that's this Tune 2 sign. The last 3 ports go to all of the piece stakes and the mini trees. For the piece stakes, there are 2 groups. There are a total of 70 piece stakes, and the strands are in sections of 10. So there are 40 on this side, and then there's 30 on that side. And these go to ports 2 and 3 on the second receiver. The section with 40 has power injection, but the section with 30 does not. And then we have the 5 mini trees, and all 5 of these are on 1 port. But let me finish with the piece stakes first. So for those of you that don't know what a piece stake is, it's basically a stake that has pixels in a row. A guy called David Peace invented these, and he was the first one to make the Peace stake. You could do really cool designs if you have a lot of them. Like you can have them all wave. And people now have made designs with different shapes and sizes. There'll be some with 10 pixels, there'll be some with 5, there'll be some with 20 that are really tall. Some of them even have a star on top of each of them. To keep this video short, if you want to learn more about the Peace stakes, I'll leave a link to a video right there about them, because there's a lot of details about them, where I got them from, and how I built them. Each Peace stake has a wire going between them. So for the section of 40 on this side, the wire goes from the top row over to the second row, and then to the third row, and then back to the fourth row. And then I tried to keep them a little random, because if they're close together, they block each other. We have some different wires down here that go to a bunch of different places. This is the first Peace stake for the, right section if you're looking from the road. And then this Peace stake is the first section for the left side of them. Those wires both go into that controller box along with all the power injection. This Peace stake right here is the one with power injection. This is the last one for the strand of 40. And this is the last Peace stake on the strand or section of 30 Peace stakes. And the pigtail I just put back in there. There's no power injection for it. And then for the 5 mini trees, I ran out of ports to put everything on. So I had to put all of these on one port. I'm hoping to put another differential receiver, or again, SRX 2 or 4 differential receiver to put in that box. But I had to do a lot of power injection since these are all on one port. These trees are the mini trees from Boscorio Studio. I don't remember which ones they are. I'll show it on the screen. You can get them in black, white, or green, and I chose green since the trees are green to make it look a little more natural. Each of them have 70 pixels total. There's 50 pixels in the tree and then 20 pixels in the star. The trees come with a star, and it comes with everything to keep the star mounted. It also has a back cover on the back. And what we did to get these in the ground is we took the same size rebar we did for the candy canes, just a little bit shorter, and we zip tied it into the back, and it already has holes in it, and then just shove that in the ground. Since it's close enough to the ground and there's a lot of area to it, it doesn't spin that much, so it's perfectly fine. These trees were a little bit smaller than I was expecting, but I honestly like them. If they were bigger, they might have blocked more stuff, but I like them like this. All of the trees are the same. This is the first tree right here on the row. Has data coming to it, and then it has a wire going to this one, and then a wire going to this one, and then this is the third one, and it goes into the fourth one here. And these have 2 power injections on it. There's one at the last tree, and there's one in this middle section right here between the 3rd and 4th tree. Right here in this whole jumble of wires, the wire that comes from tree 3 to tree 4, there is a T before it goes into here, and that T has a power injection wire right here. This is the power injection wire, and it also has a pigtail in the middle of the power injection wire to plug into here for the power injection for this mini tree. And then there's also the data wire that hooks the 2 together. And then that power injection wire that has the pigtail in the middle right here, you can see that right there. There's no data or anything, it's just power, and that goes up to that controller box. And that is everything in the yard. Next we have the father of mini trees, the mega tree. This tree has been in the show since the 2021 Christmas light show, and it is a 12-foot tall tree with a 3-foot tall star on top. So it's a little bit over 15 feet since the star hangs a little bit higher than that. There are 24 strands of lights on this tree, and all of them are 12 volt bullet pixels. If I haven't mentioned it already, all of the pixels in this show are 12 volts. I don't really do anything with 5 volts. There's a lot of different pieces to this tree, and I'm hoping maybe one day I can make a separate video about it so I don't have to rush through it every year. But starting off for the tree, I will talk about the controller box right here that used to control just the tree, but now it controls more. Only 2 wires come to the tree. We have an Ethernet cable, and then we have a main power cord. Inside there are 2 of the new V5 SRX 1 differential receivers, and then I have a power distribution board, and then behind there I have I think it's a 100 amp HP server power supply. So this thing can power a ton of pixels. I didn't want to have to fit 3 Meanwhile power supplies in here, so in 2021 I got the massive power supply. I'll try and show it to you after I talk about this, but it's behind this plate that holds the power distribution board. The tree, like I said, has 24 strands to it, and there are 6 sections to it. Each section has 4 strands to it. So on one port there's 4 strands, and that's across 6 ports. I'll tell you what the other 2 ports go to in a second. They do go in order, so port 1 over here goes to section 1 of the tree, then port 2 goes to section 2, port 3 goes to section 3, and so on. On the second differential receiver, I have the other two strands for the tree, and then one port goes up to the star, which I'll show in a second, and then the other port goes to the window that's all the way on the left of the house, and I'll also show that in a second. We have an Ethernet cable that jumps from this receiver over to this receiver. On the HP server power supply, I have a board from Wizard of Wire, and I'll just take this off so I can try and show it to you now. And if I break it, it doesn't matter because I'm taking apart the show later today anyway. So here's the HP server power supply, and technically for me, it cannot output 100 amps. It can only output 75, because if you want it to output 100, you have to input 240 AC volts to it, but I only have 120 going to it. And then I have, I think it's called like a break-off board from Wizards of Wire. It has fuses on it, and the HP server power supply, they don't have terminals on it. It has this little metal bar, which I'll try and show you. If you look right there, that is the metal bar. So this slides onto it. It's actually not metal. I don't know what it is. It's conductive though. So it slides onto there, and then it gives you terminals to go to whatever you want it to go to. It has 4 positive and 4 negative terminals. 2 negative and 2 positive go to the differential receivers down there, and then the other 2 come into this power distribution board. I got this from Hanson Electronics. Actually, I don't think I got this from Hanson Electronics. It's from Hanson Electronics, but I bought it through Wired Watts. The way I have it sticking onto this metal plate is I have these little sticky tabs that have a spot to go through the screw holes on the board, and it sticks to it, holds it on great. And then I have 7 power injection wires that come out. So it gives you 8 outputs, and one of them has a built-in data booster. I'm not sure how it works. I've never used it, but there are 7 power injection wires coming out. 6 go to the strands for the tree, and the 7th one goes to the star. There's 7.5 amp fuses on this, and that is everything I think in this box. Some extra information I forgot about the box. I bought that as a kit from All Things Pixel. So the power supply, the mounting bracket, and all of the pieces that hold it together, and the sticky tabs all came from there. But All Things Pixel website does not show up anymore, and it does not work. So I am not sure where you can get this kit from. I know you can get the power supply from Wizard of Wire, but for the rest, I'm really not sure. Sorry about that. Now, all those wires come out down here. Half of them go to this section of the tree over there. There's tons of wires everywhere. I couldn't tell you which wire goes where without having to move it around and feel which way it goes. And then the other ones go over here to this section of the tree. And then 2 of the wires right here, the data and power injection wire. This big black one's the power injection, and the gray, or the brown, is the data wire. Those go up, they're zip tied to the pole of the tree, and they go way up to the star up there. Now the extra data wire that comes out comes over to this window right here, and then goes to the wreath right there. This window used to be on the same port as that window, which plugged directly into the controller in the garage. But when I added this wreath here, it would have been too much to keep on that port. So instead, I have it coming off of this box. That way, it's not also on the same port as the door and this window. So it comes over, goes into this window, goes around this window, and then it comes out into this wreath right here. I don't remember what size wreath this is. I'll put it on the screen, but this is from Boscoyo Studios, like everything else. It's, again, another prop that has 99 pixels in it. So the extra pixel that goes to nothing, I just have laying back there. I didn't want to cut it off and solder it. It's just a simple piece of coral that holds all of the pixels in, and I just took really long screws, screwed it in at all 4 sides, even though it's a circle that doesn't have sides. Just screwed it into the wall. The reason I did this is because we're getting new siding next year, so it doesn't matter how many holes we put into the wall or whatever. So my dad just said, screw it in the wall, he doesn't care. But coming back over to the tree, now I'm gonna explain how it is built. So at the bottom, I have 2 4x4 beams that cross each other. This one right here is the bottom one, and there's an indent in it, and so the top one can sit on top of it. There's holes that go through both, almost to the bottom of this one, but it doesn't go to the bottom. And then this pole, this is the main pole that holds the tree up. This goes into that 4x4 base. I can never ever remember the size of this pole. I'll put it on the screen. I think it's a pole for a fence though. One section wasn't long enough, so we had to get 2 sections and cut it, and they fit together here like a normal fence post would. And then we have screws going through it to hold it together. And then it goes up into that ring we have up there. And that is a ring also, guess where it's from? Boscoyo Studios. Last year I took my GoPro and got pictures of it from up there and put it in last year's behind the scenes, so I'll reuse those to show you. But it has 32 holes in it that you can attach hooks into it. So we have S hooks going in 16 of the holes, and then we have all 24 strands hooking to the 16 S hooks. And then for the star, I want you to guess where it's from. Put your answer in the comments. It's from Boscoyo Studios. It's the 36-inch chroma star with 6 rings, and it has a piece of PVC pipe that goes down into the fencing pipe, and it also has screws to hold it into the fencing pipe. And then the piece of PVC pipe has a hole in it, and one zip tie runs through the hole, and then the rest run around the piece of PVC pipe to hold the star up. Also, this year we added zip ties that you could see right there and there that go to the ring, and it holds the star from spinning back and forth. That's what we added this year, so those work great. One thing to note about the ring, please, if you get this, do not over tighten it, because if you do, it will break and you'll be very frustrated. It happened to us with the ring below it right there. That is what holds the guy wires, which I'll talk about in a second. If you're afraid of it sliding down when you tighten it, you could do what we did, and we put a bolt underneath it, which you cannot see really. We put a bolt under there though, and it holds it from sliding down, so that way we don't have to worry about the weight of the strands pulling down the tree. And then a little ways below it, we have the ring that holds the guy wires. We have these guy wires right here. There's 3 of them. One goes that way and one goes that way. Then the other comes back here, and they are staked into the ground with a small piece of rebar. It came with the kit that ring came with, and that's everything for the top of the tree. All of the strands are hooked together. So for example, this is the last strand right here, but data starts here, it goes up over to the next strand, comes down over to the 3rd strand of that section, goes up, and then comes back down, and then power injection is on that side. And that would complete one section. So all of the pigtails are hooked up properly for their strands up there. And then we have data and power wires coming in down here. To hold the strands down, we have the little hooks with the loops on them. I am not a good hardware guy. I don't know the name of it. But we twisted that in here. And then there's a piece of 1/2-inch PVC pipe that goes around the entire thing, goes through another loop right there that's screwed into the board. Then there's a section right here where we had to hook another piece of PVC pipe in since one wasn't long enough, and that goes over to there. And then I zip tie each strand to the piece of PVC pipe. But if you're doing this, do not go from one side all the way around. Go back and forth. So like start with that side, then this side, then this side. If you have a 360-degree tree, do all 4 sides first, because if you slowly work your way around, it pulls the pole back. And with a 180-degree tree, it's really bad because all of the strands are on the front, so it keeps trying to pull it down. These strands were a lot tighter when I put the tree up, but now they have gotten a lot looser since it's been pulling the tree forward. So next year, I think I'm going to extend the pipe to go all the way around and take a few pieces of strip or something to hook it to the ring at the top and pull it down here. You could see, even looking right here, how much the thing is pulled forward at the top, and I'm afraid it's going to snap, so I'm going to be taking this down literally today. And I never cut these zip ties the extra off, because sometimes I'll need to tighten them to adjust it. But when I'm done and ready to pick up, I'll just cut all the zip ties. And then there's also tent stakes that hold the piece of PVC pipe down. I have 3 of them, and I take a zip tie and put it onto the pipe. That way it holds the pipe and doesn't pull it up. And then in the front, I have some boards underneath the front board. Our ground is very unlevel, so that keeps it from tipping forward. And then that's it for the tree, and the final thing is the roof. Now up here on the roof, we have the final controller box right here. And inside here, it's basically like the controller box in the yard. But instead of having one 12-volt power supply, we have 2 in here. Now when I'm pointing at everything, I'm gonna have my hands inside my sweatshirt because I'm freezing right now. The roof really needs 2 power supplies because there's a lot on it. So that's why we have 2. And then we have 2 SRX 1 differential receivers. We have one version 2.01 and one version 4. There's 1 power cord and 1 Ethernet cable that comes to here. And we have the Ethernet cable coming into the first receiver, which is the V2 one, and then the Ethernet cable jumping to the second differential receiver. We're using 7 out of the 8 ports in this box. the first 7 right here, one of them goes to the roof, the other 3 go to the singing faces, and then this receiver goes to the snowflakes up there. It plugs into here, and this one extension cord goes to both power supplies because you can run up to 2 off of one cord. I've heard some people use 3, but I personally don't go over 2 just because I want to keep it safe. Now for the singing faces and the roof line, I talked about it in the Halloween light show, so if you want more detail about it, I'd recommend watching that. But for this, I'll quickly just explain how it works. We have a data and power injection wire that runs down there. That is the corner of the roof. It starts on the front, comes all the way down, up and around the entire roof, and then power injection is at the end. And in the corner of the roof, right there, I know you can't see much of anything, but there's a power injection over there. The roof is on all one strand, and then each singing face is on its own port. There's no power injection for those. The way the singing faces are held up is there's a little frame that comes off the back and goes onto the roof. It's at an angle, so it fits the pitch of our roof. And then we just have a sandbag on top of it. And every year, it holds it amazingly well. These singing faces have been up here since probably the middle of September, and it's now January 1st. They went through the Halloween and Christmas light show, haven't moved a bit. These hold even with the wind, it's great. And then the way the snowflakes are hooked up, there's 3 groups of 2. These last 2 are on a group, then the middle 2 are together, and then the last 2 are on a port together. Each of them have power injection, and I don't remember which side the data comes on, but I think it's different for each of them. And then we have one long power injection cable that goes up and power injects each section of those. And the way it works is, I think this is the power injection wire here. There's a lot of extra. It just has a male pigtail in the middle of it where it needs power injection, and then it just hooks up to all of those. I forgot to mention where these are from. Surprisingly, they're not from Biscorio Studios. These are all snowflakes from Gilbert Engineering. 2 of them are the A flakes, 2 of them are the I flakes, and 2 of them are the K flakes from Gilbert Engineering, and we have 2 of each. Those are also held up with a frame and a sandbag, and I actually got up there when one of them died, so I took a few pictures so you could see how they work. The frame comes down, the sandbag sits on top of it, and then I can't remember if it's bolts or pins or what it is, but there's something that holds the PVC pipe going from the top down, and they don't spin at all. It holds it great. And then the PVC pipe, I'm not sure how well you could see it from here. It's screwed into the snowflake there and there at the top and at the bottom, and it holds it amazingly well, and it's worked for, this is the 2nd year, and it worked great for this light show. And then the way the controller box is held up here, it also has a frame built for it, and it has the correct degree so it can match the pitch of the roof, and it has a sandbag on top. Everything has an inline fuse for all the power injections since there's no distribution board in there. And that is actually it for the roof. There's not much. I know I didn't go into great detail about each thing, but I'm sure the video is over 30 minutes long, maybe even 45 minutes. So if you want to see more detail about this, go watch the Halloween behind the scenes. Now, 2 last things before I end the video. 1, I'm going to measure the amperage with all the lights on so I can show you what that is. And then I also want to show you these tags. These are the tags I got for labeling wires. I don't remember where they're from, but I think you can find them on Amazon. And what you do is you write on both sides of this, and then you fold it over the wire, or, no wait, this goes around the wire, and then you fold that over the extra tab that goes around. Like I said, the marker has faded off. This is my first year using these, but for storage, I think it should work fine so I can remember which cables go where. And then it also came with a bunch of different color ones. So I have red, I have blue, I have pink, and there's other colors inside. So I could color code data wires with red and Ethernet cables with pink. But now I'm going to use my handy dandy kilowatt meter. This is the P3 kilowatt meter. You can find this on Amazon. It's spelled kill-a-watt, so that's how you have to look it up. It can measure the volts, amps, watts, hertz, and kilowatt hours, a whole bunch of other things when you plug it into an outlet, and then you can plug your load into here. I think it can only handle up to 15 amps. Yes, max current 15 amps. So if you have anything over 15 amps, you can't measure it with this. But for the light show, it doesn't take over 15, so I can measure it. So first, I'm going to measure everything but the screen, since I can't hook the screen together. So I just hook that in there, and then you'll notice it comes on. It shows that there's 120.2 volts, and for amperage, there is 0 amps right now. Now I'm going to plug this in, and now this is just with power going to everything. Transmitter, Raspberry Pis, and all of the pixels are on, the microchips are on, but the lights aren't on. And that already takes 2.54 amps, or around there. But now if I go and activate a test pattern of all white, we will see how many amps the total pixels take. So there you go, white test pattern. all of the lights are on white right now, including everything up on the roof. And let's see. And we have 7.85 amps. So that is with everything except the screen. So the whole light show takes 7.85 amps. The pixels are running at 30% brightness. If they were running at 100, it'd take a lot more. But since the lights aren't always on white all the time, they're always doing patterns and not using their full brightness, this is usually lower. This is the highest it can get. Now, so I can measure the last part, I'm going to plug in the screen to the kilowatt meter. And just know when I say kilowatt meter, it's not just for kilowatts, it's just literally called kilowatt. So that's why I'm calling it kilowatt. Right now, with the screen not on, or with the screen technically on, none of the lights are on, it's taking 0.25 amps. So here we go, I have the whole screen on white. You'll notice there are a ton of blotches that look messed up. And if you look from the front, it's actually really weird. They almost all go away. When you look at the screen directly from the front, you'll notice a lot of flickering. That's just because the camera can't pick it all up. But the reason you see this when you look from the sides is all of the covering for each of the panels has been peeling off, and these panels have just been a piece of junk. It may have been the temperatures going from warm to cold. Maybe that might have done it, but even at the corner of all of the panels, you can see like this panel's lifting up. They're just really bad panels. You could push them back on though. Like if I just push really hard right here, you could start to see that I'm pushing the panels pieces back on, and then it goes away, but they'll just pop off again later. But now we have the panel on all white taking maximum power. Let's take a look at what the kilowatt meter says. And this is reading 6.1 amps when that's on all white. So if I have the whole display on white with the panel on all white, it'd be taking about 13.5 amps. This is all on its own 20 amp breaker though, so I don't have to worry about it because I'm not near the limit. And everything's never on white, except for maybe like 1 or 2 seconds of a song, maybe once an hour. So I don't really have to worry about this, but for anyone curious, that's how much power the light show takes. So that's going to conclude it for the 2023 Christmas Light Show behind the scenes tour. I know there's a ton of stuff in this video, and it seems like every light show, the video gets longer and longer and longer because there's more and more stuff in the show. I know there's a lot of things I didn't go into a ton of detail about how exactly they're built or how you can build them, and it's probably because I talked about it in the Halloween behind the scenes video, and if I didn't, please let me know down below if there's a certain prop you want to see a video separately about how I build it and how you can build it. Like if you want an arch video, or maybe a video about how I build a snowflake, anything like that, please leave them in the comments below. Also, if you read my community post, you'll know that I was talking about the next video is going to be a reflection type video, just to talk about everything that happened in 2023 and what I hope to do in 2024. And I'm also going to be doing a Q&A in that video, so if you have any questions you'd like answered, leave them down below in the comments in this video and I'll answer them in that video. Just make sure you say in the comment for a Q&A video. But that's going to conclude it for this video. Now I can go outside and rip down the entire light show and not have to think about pixels for the next couple months. Thank you for watching, and I'll see you in the next video.